In this third tutorial we want to explain you sizing of the inverter for solar system, also sizing the DC connections, and some advanced analysis and shadow analysis, and how to export your single line diagram to DXF. Yeah. After we draw the field segment, we choose the models, we draw the key pouts and everything. Next step is to choose the inverters or to size the inverters. Helioscope will like automatically give you suggestion to number of inverters and inverter size. Here you see this, it is what is the nameplate of our system in kilowatt panel, and also what is the 8 nameplate, 22.2 kilowatt panel, and this is the DC or AC ratio. Here you can manually choose the inverter from this library. You can just maybe put like the power, as I said you, or manufacturer. You see like 30 kilowatt inverter. I want to use, let's say, 30 kilowatt inverter. Let's say some, maybe Fronius or SMR. Let's say this one inverter. It is the power of inverter is 30 kilowatts. You see here, this is count of the inverter is, let's say, 2, and here we can like manually put, let's say, number of inverters, or it can be count automatically. Here we can adjust what is the ratio of DC AC. It is always good to inverter to be, let's say, smaller power than the DC nameplate. Let's say in this case it is maybe something, inverter is 30 kilowatt amps and the DC nameplate is 61.7 divided by 2. Let's say it is around 31 kilowatt of the panel, because panels are not going to work all the day with the biggest efficiency, so it is okay, let's say. Okay, here you can also put the subsystems, or maybe here you can use set the manually stringing of the inverter. Let's say for this inverter is the, let's say, from 10 to 17 panels for one string, and we can here go to show all details. It can show what is the stringing, allow the racking or up and down. You see here at this picture it is changing these two wiring diagrams. It is changing, and also what is the cross section of DC connections. You can here choose from the library what is the cross section in the AVG. Okay, let's say it is 10 AVG copper, and losses are 0.5% in this case. Okay, here if you click on this inverter, you see what are the modules which are connected to this inverter. Okay, this yellow one. Okay, and this is the second inverter. These are the panels which are connected to this inverter, so we can put it here. Okay, and these like small blue lines are the connections, DC connections between inverters, and these two small boxes are these like DC subsystems. We can also maybe remove them. It will be removed, or add combiners to add like DC boxes for these inverters. Okay, next step is the sizing of the DC connections. We have done it. Also, next step is the shadow analysis of this one. Shadow analysis of this project. We can click on the shadow, do the shadow calculation from the nearest point, and program will do for us shadow analysis. You see here that shadow analysis give us 1.3 shadow losses, so it is around 1.3%. It is not too much. if you go and small this one, yeah, it will give you what are the models which are more affected. It will be this agree one models. If you go and make this make this value smaller, it will be 2 models, this 3 agree one, and maybe we want to like delete and remove these models which are more affected. Let's say here, let's say we can remove these 3 shaded models, so I want to remove them. Okay, here, yeah, it is the shadow analysis. Yeah, shadow analysis is finished, let's say. And next time we can also now go and see what is the single line diagram. Here it is the single line diagram. If you click on the single line diagram, it will give you a review of the single line diagram. So it is connection of the panels for DC combiners and then to the inverter. Yeah, these are types of the inverters. These are 2 same types. These are what are the specification of the models, what are the basic information, voltages, currents, also for the inverter. These are also what are the wire schedule, what are the length of the DC cables. Here, yeah, it is the single line diagram. You can also go and export it to PDF, so it will be exported to PDF and you can open it in AutoCAD. So it will be like this. So you can always go and, yeah, or rename something. If you want to do something, you can now do it in AutoCAD. So it will be, yeah, it gives you a lot of options. You can now go back to this diagram and just go and click on the save this analysis, and yeah, it is ready for the next step. Yeah.